Earthquakes are an undeniable reality for every living being on Earth. A sudden release of energy in the lithosphere creates seismic waves that lead to the trembling we feel on the surface. Most earthquakes are so weak that they can't be felt unless you're using sophisticated seismic activity monitoring tools. But humans have also seen quakes strong enough to propel objects and people into the air and even wipe out entire cities. In the past, earthquakes have caused a lot of destruction to human settlements that were close to or right above the fault lines. One such continental transform fault is the infamous San Andreas Fault. Multiple earthquakes have occurred at the San Andreas, the most notable one being the 1906 San Francisco earthquake that killed almost 3,000 people. Seismologists and geologists have been keeping a close eye on the San Andreas since the last quake occurred on this fault line, as it is no less than a ticking time bomb. They know that a massive event might occur any time now, and California needs to be prepared for it. But why exactly are experts so concerned about the San Andreas fault line, and what will happen when the massive event they're dreading actually occurs? There's also the matter of newer kinds of earthquakes we are just finding out about, and how will humanity deal with this game-changing information? Let's find out. The San Andreas Fault line is roughly 1,200 kilometers long, and it forms the tectonic boundary between two individual continental plates. These are the Pacific Plate and the North American Plate. The slip rate along this fault ranges between 20 to 35 millimeters per year. Professor Andrew Lawson of UC Berkeley was the first one to discover the northern zone of the San Andreas back in 1985. He also reportedly named the fault after the surrounding San Andreas Valley. In 1953, Thomas Dibble, a geologist, found out that hundreds of kilometers of lateral movement could occur along this fault. The San Andreas Fault is divided into three distinct zones, with each one having its own unique characteristics. Each segment also has a different degree of earthquake risk associated with it. The northern segment runs from Hollister all the way to Mendocino Triple Junction. The central segment runs in a northwestern direction from Parkfield to Hollister, and the southern segment stretches from Parkfield in Monterey County to the Salton Sea. The Pacific Plate that lies to the west of the fault is moving in a northwest direction, while the North American Plate is moving towards the southwest. However, it is relatively southeast under the influence of plate tectonics. The seismologists have discovered that this southwestward movement of the North American Plate towards the Pacific is causing compressional forces to build up along the eastern side of the San Andreas. This is expressed as the coast ranges. The northwest movement of the Pacific Plate is also creating enormous compressional forces that are particularly pronounced in the region where the North American Plate has forced San Andreas to move westward. This has also led to the formation of transverse ranges in southern parts of California. Experts are speculating that if the plate boundary does not change as hypothesized, the landmass west of the fault line, including Los Angeles, will eventually slide past San Francisco and continue northwestward towards the Aleutian Trench. This will, however, take a long time, almost 20 million years to be exact. The San Andreas reportedly began to form in the mid-Cenozoic era almost 30 million years ago. Recent research has revealed that near Parkfield in central California, the San Andreas Fault is consistently producing an earthquake of 6 magnitude almost every 22 years. These seismic events have been recorded in 1857, 1881, 1901, 1922, 1934, and 1996. Owing to this data, scientists have predicted that another earthquake would occur in Parkfield in 1993. But as it turns out, they were off by a few years because the earthquake did occur, but not in 1993. It happened in 2004. This frequency of predictable activity has rendered Parkfield one of the most important areas in the world for large earthquake research. Work on the San Andreas Fault Observatory at depth began in 2004 just north of Parkfield. SAFORD is trying to drill a hole almost 3 kilometers into the Earth's crust and into the San Andreas Fault. They had planned to install an array of sensors that would record earthquakes occurring near this area. The fault line has also been a subject of many flood studies. Many frightening earthquakes have rocked the ground around the San Andreas Fault in the past. These include the 1857 Fort Tejon earthquake, the 1906 and the 1957 San Francisco earthquakes, the 1989 Loma Prieta earthquake, and the recent 2004 Parkfield earthquake. For a few years now, scientists have voiced their concern about the dreaded Big One. In 2006, a study was published by Yuri Fialko, an associate professor at the Green Institute of Geophysics and Planetary Physics at the Scripps Institution of Oceanography. It revealed that the San Andreas Fault has reached a stress level sufficient enough to set off an earthquake of 7 or greater magnitude. It was also found in this study that the risk of a massive earthquake was increasing faster than the scientists had anticipated. The director of the Southern California Earthquake Center made a bone-chilling announcement about this impending quake a few years ago. According to him, the San Andreas Fault appears to be in a critical state and could generate a large earthquake at any moment in the coming decades. This isn't a new thing for Californians, however, as we've established that the region has endured its fair share of earthquakes in the past. But experts have warned the population that the southern portion of the fault looked like it was locked, loaded, and ready to go. So why exactly are seismologists alarming the public? It's because there hasn't been a major stress release event in the southern part of the San Andreas Fault since 1857. Some stress between the two plates is building up quite rapidly. Some of it was released with the catastrophic 7.8 magnitude 1906 San Francisco earthquake, and later in the 1989 6 magnitude Loma Prieta earthquake. The southern segment of the San Andreas Fault hasn't seen an event of this magnitude as of yet. This has led scientists to speculate that one enormous earthquake in this segment is imminent. Owing to the high amount of stress this segment has accumulated, they're afraid that it will be the big one. Strong earthquakes have occurred in the central and northern segments quite recently, but it's been 300 years since a major rupture in the southern segment occurred. According to Yuri Fialko's study, a major quake in this part of the San Andreas Fault will cause major damage to the Palm Springs-Indigo metropolitan area. Other cities in San Bernardino, Riverside, and Imperial counties of California and the Mexicali municipality will also suffer significant damage. The earthquake would be strongly felt throughout Southern California, including the densely populated areas of Los Angeles County, Ventura County, Orange County, San Diego County, Ensenada Municipality, and more. Experts have warned that older buildings will be more prone to damage or collapse. Buildings built on unconsolidated gravel or in the coastal areas with high water tables will also be at risk. Fialko has emphasized that all this data suggests that the fault is ready for the next big earthquake, but we cannot tell when the triggering and the quake will exactly happen. It could be tomorrow, it could be 10 years from now. It's been more than 16 years since that publication, and so far Southern California hasn't witnessed a substantial earthquake. But even if it were to occur anytime soon, our current ability to predict earthquakes with sufficient precision is not reliable enough for an event of this extent. The most recent forecast by the U.S. Geological Survey is called Uniform California Earthquake Rupture Forecast 3, and it estimated that an earthquake of 6.7 magnitude or greater tends to occur almost every year in the state. This report also estimated that there's a 7% chance of an earthquake of magnitude 8 or greater occurring somewhere along the San Andreas Fault in the next 3 decades. A different USGS study from 2008 tried to predict the physical, social, and economic consequences in case of a major earthquake in Southern California. That study speculated that a 7.8 magnitude earthquake along the southern segment of the fault would cause around 1,800 deaths and financial damages amounting to a whopping $213 billion. California seems to be the hub of impending natural disaster. The fear of the big one was enough to keep the Californians awake at night, but now researchers have discovered a newer kind of earthquake. The Southern Californian researchers have found that this new kind of earthquake can occur much deeper than anticipated, almost 24 kilometers deep in the upper mantle of Earth. It can't be detected using traditional seismic sensors. These deeper quakes bear the potential to make earthquakes much more destructive than previously predicted. Until this discovery, scientists believe that earthquakes only occur in the top half of the Earth's crust. It was thought that earthquakes in Southern California didn't happen deeper than 10 to 24 kilometers. This is because below that lies the mantle, which is incredibly hot, and the rock at that depth becomes a honey-like liquid in which seismic strain cannot build up. But the team from Caltech Pasadena used some of the most sensitive seismic sensors and detected tiny earthquakes occurring along the Newport-Inglewood fault line. These quakes were deeper than 24 kilometers. This is the same fault line at which the gruesome 1933 earthquake occurred and killed about 115 people in the Long Beach area. So far, the deep earthquakes detected along the fault have been minor. The highest magnitude recorded was around 2, but the team believes that earthquakes extending this deep are capable of rendering future earthquakes much more disastrous. One of the researchers named John Paul Ampuero has stated that if earthquakes want to get big, one way of achieving that is by penetrating deep. So if the next large earthquake penetrates deeper than we think, it could also be bigger than we assumed. The Newport-Inglewood Fault is the same type as the San Andreas. This means that the longest fault line of California, the San Andreas, may also start experiencing these deep earthquakes. The researchers have begun looking into the possibility of these deeper earthquakes after the April 2012 quake in the Indian Ocean that struck just off the coast of Sumatra. It was registered an 8.6 magnitude earthquake and was considered the largest of its kind to ever have happened. It occurred on a fault known as the strike slip that is also the same type as the Newport-Inglewood and the San Andreas faults. Experts were having a hard time explaining how the Sumatran earthquake got so big. Existing science was unable to answer this question. The only logical explanation was that the earthquake went deeper than the crust, all the way down to the mantle. Now the Caltech team has figured out that this is also possible for the Newport-Inglewood fault line. In case a shallow quake on this fault extends deeper into the mantle, it could reach the strength of a magnitude 7.4. This is bad news for the entire Southern California region, which is already facing the threat of a huge quake at the San Andreas Fault line. For now, researchers know very little about this new type of earthquake. They are concerned about these, but they've also admitted that these deep quakes could also just be small localized chatter and won't link up with each other. So there's a chance these may not affect the quakes occurring closer to the surface. Ampuero thinks it's good news that these deep earthquakes never break together. It means they can break in tiny quakes, but not in larger ones. Right now, they need to further investigate this discovery on multiple fronts to better understand the physics of the Newport-Inglewood fault line. Only time will tell how dangerous this new type of earthquake really is and what type of threat it poses. It's probably not as bad as the recently found unconventional earthquakes being triggered by hydraulic fracking. What do you think? Tell us in the comments below.